So today we are looking at factorization of algebraic expression. Factorization of algebraic expression. Okay, so factorization, okay, of algebraic expression. Okay, factorization of algebraic expression. It is a lot, okay? It's a lot. So we are going to take it one step at a time. So we move from simple ones to the complex ones, okay? Using different method of factorizing algebraic expression. So the first one we are going to look at is a very simple problem. What do we mean by factorization? Factorization means that we are trying to bring out what is common between two or more algebraic expression with them returning their sign, okay? With them returning their sign. Let's take, for example, if I'm to factorize, 8x plus 2y. The question I have here is that these are two expressions, 8s and what? 2y. Okay? Two expressions, 8s and 2y. The question I have now is that what is common between 8s and what? 2y. What is common between 8s and 2y? Okay? So in factorization, your job is to bring out what is common between two or more different algebraic expression. So in this case now, of course, we have a video on HCF. Is very, very useful here because when you don't know how to do your HCF, you will find this very difficult to do. So I will encourage you to go and watch our video on HCF before coming to do factorization of algebraic expression. Okay, why am I saying that it's going to be helpful? Okay, let me just do a little of HCF here. If I have 8y 8s, sorry, plus 2y, okay, I first of all need to get the highest common factor of these two. So I have 8s and 2y. So 2 can go in both. So I have 4x and y. That is the only, so the HCF is equals to what? 2. So 2 is the HCF of these two terms. So what does that mean? Or how does this HCF, very important to factorization? That is because the factor, the HCF is actually what is common between these two terms. So that will give you 2 into, what do we have here? We have 4x here. So we are going to have 4x here. Of course, the sign will remain. Then we have y here. Okay. I'm not saying that you should keep doing this to be able to do this. This is just to tell you that how important HCF is to factorization of algebraic expression. Okay, so it's very important. That does not mean that we cannot solve that without doing all this. Okay, now how can we do that with? I ask myself, what number or what expression that can be able to divide this that can also divide this? Okay, so if you look at this now, 2 can divide this, 2 can divide this. So I can start with that. If I do that and still have something that is common, I can equally bring it out. Okay, but luckily for us here, there is nothing else that is common to bring us. So we have factorized this expression. So that is the reason why you need to go and watch the video on HCF so that you can be able to work on factorization. So now let us solve more problems, okay? So factorize the following. So our number one, we have 30AB 30ab minus, let's say 15ab square. Okay, 30ab minus 15ab square. So we ask ourselves, what are the things that are common? 15 can divide this, 15 can divide this. So 15 is common. Okay, a can divide this expression here, and a can equally divide this expression here. So a is common. B can divide this expression here. So you can use B to divide this expression. You can equally use B to divide this expression. So B is common. Okay? So if you do that, 30ab, since we've been able to get what is common here, 30ab divided by 15ab. That will just give you what? 2. Minus 15ab square divided by 15ab. So we have only b. Now, if you still use this method, being able to find the HCF of those two terms there, so that will give you 30ab, 15ab square. So you use what is common. 2 can go in both. Oh, 2 can go, 15, 5 can go. So 5 here will give you 6ab, 5 here will give you 3ab square. So 3 can still go. So I have 3, 2ab, and 3ab. So a can go. So when you use a to divide, you have 2b. When you use a to the, sorry, we have square here. When you use a to divide this one, you have 3ab. 3b square. So b can go. So when you use b, you have 2. When you use b here, you have 3b. Okay? I think there's an error somewhere. When we use 3 to divide this, okay, we are not supposed to have this 3 anymore because it has been cancelled out here. Okay? So you can see that when you multiply this, our product here, our numbers here, okay, you have 5 times 3 times a times b. That will give you 15ab, okay, being our HCF. And when you have your 15ab, what do you have left on that first expression is 2. Your sign remain, which is minus. What do you have next is b. Okay, so of course you put it in brackets because you can't leave it like that. Number 2. Okay, let's have 7GH minus 21GHK. Okay. Okay, let's put a square there. Okay, so with this now, we do the same thing. What is common? So 7 can go in this first expression, 7 can go in this second expression. So we have 7. G can divide here, G can divide this one. So we have G outside. H can divide this, H can divide this. So we have H here. So when you do that, 7GH divided by 7GH, you have 1 left, minus 21 divided by 7, that will give you 3. G divided by G will go. H square divided by H square, we have H remaining. Then, of course, K is still there. So you can see it's very simple. It's a very simple thing to do. Okay, we are going to solve a whole lot of examples. I have some examples here that I've listed out, so I can I have some examples here I've listed out for us to solve. So we are going to solve them gradually. So number 3 is 9s squared yz squared minus 12s squared z squared. Okay, let's take this z as cube. Okay, very simple. We ask ourselves, what can we use to divide this that can also divide this? 3 can go here, 3 can go here. So 3 is common. S can divide this expression. I can see S. In fact, S square, not just S, because there's S square here, there's S square here. So I have S square outside here. We have only Y, so Y can divide both. We have Z square. We have Z square here. We have Z cube here. So Z square can divide both. Okay. So when you do that, you open your bracket to write whatever that is left. Okay. The whole of this divide by this. You can equally do this one step at a time. 9s square yz square all over 3s square z square. Z square will cancel this will cancel this one will give you 1, this one will give you 3. So what you have is 3y. So you have 3y here minus, you can equally do the same thing that I've done there. Okay, let's do that. 12 s square z raised to power 3 over 3s square z square. S square will go. 3 here, 1, 3 here, 4. 2 of the z will cancel 2 of the z, remaining what? 1 of the z. Okay? So, you now have 4z remaining. So, minus 4z. Okay? So, that's how that goes. So, let's solve one more example on those simple ones. So, we have 9. Oh, we have solved that. Let's have minus 4p square q plus 44 pq square r. Okay. Now, look at this problem that we have there. Look at the problem that we have there. There's a negative outside. Whenever you look at these ones, the number that we brought out is positive. The number that we brought out is positive. The number that we brought out here is also positive. The number that we brought out here is also what? Positive. Now, in a situation that you bring out negative from the bracket, if you bring out negative from the bracket, the sign at the middle of the bracket now is not going to change. I'm not saying that it's going to be negative or it's going to be positive. It's going to be change. It's going to change. What does that mean? If it was positive, it's going to change to negative. If it was negative, it is going to change towards positive. Now let us look at it here. Let's bring out minus 4 outside this bracket. Okay. There's p squared, there's p here, so we can just bring out 1p because that's what's common. Okay. We have q here, we have q squared here, so we can only bring out q, 1q. Okay. So what you have seen outside there is a common factor. Okay. Because this can divide this can equally do what? Divide this. Okay. But now we need to be very careful. Why do we need to be very careful? Because what we have outside this bracket is what? A negative number. When we have a negative number outside the bracket, the signs inside the bracket are going to change. Okay? The sign at the middle here, this is what I mean by the middle sign inside the bracket, the middle sign inside the bracket, the middle sign inside the bracket, the middle sign inside the bracket. So the middle sign inside this bracket, because we have negative outside, is going to change. It is not going to remain the same sign, just like we had here, minus, minus, plus, plus, minus, 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 minus. In this case, it's going to change to plus to what? Minus. So what do we have? This divide by this. So minus 4 will cancel this will cancel one of these, and q will cancel q. So I have only one of the p remaining. Okay, so instead of writing plus now, I'm going to have what? Minus. That's what I said, that the sign is going to do what? Change. Now, when you say this divide by this, you're going to have 11, because 44 divided by 4 will give you 11. P will divide by P will go. Then we have Q square here and we have Q here. So when you have Q square divided by Q, you have one of the Q remaining and R remaining. I hope you can be able to understand that. Please do well to uh, check out your HCF. Okay. Now let us move away from these simple expressions. Remember, we are going to deal with all factorization of algebraic expression. So let's move away from simple expression. Let us look at a larger expression. Expression that the two terms of the algebraic expression might have a number that is in bracket, or a number that is not in bracket. Okay, so I have some of the questions that some of my students sent for me here, sent that I should solve in my YouTube video. So I'm going to solve them one after the other. So let us move to a larger number. So I'm going to wipe the board and continue with the larger number. Okay, so the first one we have, let's write our factorize the following. First one we have, okay, so these the questions my students sent that I should solve. So I have 2p squared into 3x plus y minus 2p squared. Okay, so this is what I have that I want to solve. Like I said, these ones are a little bit larger uh, uh, algebraic expression, because you can see there is a bracket, a number in bracket here. Okay, so what do we do? The same thing that we have been doing. What is common? What can divide? This one here is regarded as one expression, while this one is regarded as one expression. So the question is that this first expression here, what is common with this second expression? So by looking at it, you can see that 2p square is common. So when 2p square is common, you open a bigger bracket. Okay, you open a bigger bracket. Why am I opening a bigger bracket? Because I have something already in a bracket. So it's wise for me to open a bigger bracket that can be able to accommodate the other bracket. Now, when I bring out this one here, if you divide the whole of this by this, you have this bracket remain. So you write it out, 3s plus y minus the whole of this divided by this, you have just one remaining. So with this now, you can now open the little bracket inside the bigger bracket. So that will give you 2p squared into 3s plus y minus 1. So that's our answer for that. Then number two, we have a into x plus y plus b into s plus y. We are moving from simple to complex, okay? Now, if you look at this one, the bracket is common. Unlike this one that the bracket is not common. What I mean by the bracket, I mean that the terms inside the bracket is not common, but here, the terms inside the bracket is common, okay? So that is actually what is common. Of course, HCF, common factor. So you bring out what is common and open a bracket and put the remaining things there. So what is common here is what? X plus y. You open another bracket. When you divide this, what is remaining? A. So you have your A plus. When you divide this, what is remaining? B. That's all. As simple as that. Okay? As simple as that. Let's go to number 3. In number 3, we have 4x minus s into 3x plus 1. 4x minus s into 3x plus y. Okay? It's just like this one. Okay? Not totally like that, but a little bit like that. Okay, so we have our first term here, we have our second term here. Okay, so in the first term here, we have what? S is common with the x that is in second term. So we bring it out, we have x into what will remain here, 4 minus, oh, we need to open a bigger bracket, okay, because there is a bracket that is not common. So the small bracket there is not common, so we have it as 3s plus y. Okay, so we need to open the inner bracket there. So that will give you x into 4. This times this will give you minus 3s, minus plus will give you minus y. Okay, so let's go to question number 4. Question number 4, we have 2x minus 3y into 5z minus 2x minus 3y squared. Now, if you look at this question, there is a square now, just like this one, okay? Just like this one, but here we have square. So what would that give you? What is common first? That's what first thing to identify. You can see that this one and this, they are common. Though we have it twice here, we just have only a single of it here. So that means 2x minus 3y is common, okay? What do we mean by is common? You can get it in this term here. You can actually get it in this term here, okay? So that will give you, open a bigger bracket. What is left is 5z minus, okay, minus one of these. Since we have one of these outside already, so the whole of these divided by this, we have 2s minus 3y. Okay, so open the bracket there. You have 2s minus 3y into 5z minus 2s plus 3y. Okay, let me explain that. Minus times this will give you minus 2s, minus times minus 3y will give you plus 3y. So we have factorized that.